That's the, it's a chemical thing. I'm going to take that and I'm going to mate it with a little bit of ammonia. And that's what the amine is. So you've got chlor and then amine. I'm going to hook that up with an NH4, and it gets rid of that hydrogen off of there. But what it does, it makes it a little less reactive, and it makes it last longer in the water. Now there's a couple of benefits to that. I can use a little less concentration, and it'll get out and do a residual all the way through the plumbing system better. It'll be safer because I don't have to use as much of it, and it's less expensive too because I don't have to use as much of it. For municipalities, I can dose it into the water and I don't and use less of it. So there's a bunch of different things that chloramines are beneficial for. VOCs, volatile organics, Teflon. Everybody here knows what Teflon is, right? Well, manufacturing of Teflon puts certain things into the water. Well, manufacturing a bunch of different things. As we find out, as we become more and more attuned to what's in the water, MTBE was a fuel additive. PLFs are some of the things that we use in manufacturing for certain plastics and polymers. These are organic compounds that get back into the water system and are now part of the water supply and the groundwater supply and then the surface water supply that get back into the system. So that's what VOCs are. And they can be toxic or they can be dangerous. Carbon can be very effective at VOC removal. Heavy metals like mercury and other things as well. So that gives you an idea. Carbon is an outstanding filter for a variety of different things. Carbon is not a new material. Activated carbon has been used for a long time. The ancient civilizations realized that if they put bits of charred wood in their water supplies, in the streams, it actually clarified the water a little bit. So they understood that activated carbon had a bunch of benefits to it for their water. The insides of barrels for a lot of different alcohol aging are charred on the inside of the barrel because that activated carbon surface on the inside of that barrel can do a lot of the filtration and a lot of pulling off of the bad flavors and odors that's on the inside of the stuff that's in that barrel. So that's why they char the insides of those barrels. What do we get? So at Pentair, we make activated carbon filters. Alex, right there in front of you are a variety of different filter types, right? Mm-hmm. Every one of those filters that's in front of you has an activated carbon component to it. We'll get to that in a little bit. All of those filters that are in front of you, though, are activated carbon filters. Mm-hmm. And what we use for our carbon filters is a couple of different materials. Primarily, the thing we use the most of is coal. We also do make filters. Probably the second most common item we use is coconut shell. But we also do make some carbon filters that have a wood-based carbon as well. And you can do any one of these. Fluoride. What do we put fluoride in the water for?
Brainwashing.
Teeth.
What?
That's
Teeth. Brainwashing. Yes, I hadn't heard that one before. Fluoride in the water also has the ability to be maintenance for the walls of pipes as well. So fluoride compounds in water will actually help mend the inside surfaces of pipes and infrastructure. I believe that was the primary reason why we started putting fluoride in water. And then afterwards they found out, hey, we're getting less cavities in people that drink this stuff too. It might be good for the enamel surfaces of teeth as well. So that's sort of, I believe that it became activated carbon. Why do we use different materials? When you use different materials, here I'm going to go down here. When you use different materials and you activate that carbon, so let's think about this for a minute. When you think of coal, you think of something that's like a hard rock, black, hard surface item, right? When you think about wood, it's hard surface, coconut shell. if you think about activated carbon as a component, you start with that carbon. We all have carbon in us. Every living thing has a measure of carbon in it. When I activate it, what I'm doing is I'm taking, if you think about it like a kernel of corn, and you submit it to pressure, and you submit it to temperature, high temperature, what happens?
Pops.
It pops. That's what activates. So you're activating that popcorn. You're really not eating popcorn. You're eating activated popcorn. So that's what you should, just keep that in mind. Because the popcorn is really that kernel, right? Well, the wood and the coconut shell and the coal is your popcorn. When we activate it, we submit it to high temperature, we submit it to some pressure in the absence of oxygen, and it pops. And what that popping does, when you think about that popcorn, the activated popcorn, and you look at the surface of it, it's got a bunch of crevices, it's got a bunch of places, it's got a bunch more surface area, right? It's lighter, it's porous, butter flows through it nicely. What we do with activated carbon is we take that same kernel, we take that same chunk of coal or whatever, and we pop it, and we make it porous. And we put crevices and pores and all kinds of things, and we give it a much more effective filter capability. I can fill a tank with popcorn. I can fill a tank with popcorn and run water through it, and I'm going to filter some stuff out. Bricks, cars, birds, stuff like that, right? So I'm still going to have a filter. It's just not going to get me down to a very fine size. Once I activate that popcorn and I fill a tank up with activated popcorn, now I've got a bunch of crevices, I've got a bunch of places that stuff can get caught up in. I make a much more effective filter. So that's what I'm going to do with my carbon. I'm going to activate it. When I submit it to temperature and high pressure, what the surface does is it creates pore sizes in that carbon. And that's not jumping a big bridge, right? If I take a coconut shell and I burn it, char it, and then activate it, the nature of that's probably going to be a lot different than coal or wood. Well, typically, the pore sizes on wood-based carbons are very large. And we call that macropore, so very large. Coconut shell tends to produce pore sizes that are very small, or micropores. The reason we use coal, lignite, anthracite, things like that, as our primary source for coal, or for activated carbon, is because it produces pore sizes that are right in the middle. And that just gives us the best ability to apply to the most applications. So that's why we use coal in most of our products, is because it gives us medium-sized pores. It'll address the most issues on its own. If you want to think about pore sizes and what that works as, this is kind of a good visual of what that looks like. I want to create pores that will catch whatever contaminant it is inside of it and lock it in place. Okay? Carbon works by nature of what's called adsorption. It's porous, water flows through it. So I will catch some things inside of it just by absorption, just holding it inside like a sponge. But really what I'm doing when I'm doing chemical filtration is what's called adsorption, making it sticky. Another name for glue is adhesive. I want to adhere things to the surface. So that's what I'm going to do, adsorption. I'm going to create a lock and key type of situation. And the reason I want different pore sizes is because small pore sizes lock up small contaminants. Larger pore sizes lock up larger contaminants. So what are some of those things? Small contaminants, small, tiny, and we're talking molecular level stuff, atomic level things. Well, volatile organics, like trihalomethane and things like that, gases, very small items, are going to be best addressed with small pore sizes. So that's why if you're taking things out like VOCs that are in the water, contaminants that are in the water, most often what you'll use is what's called coconut shell carbon filters. And you'll find in the handout, in the partner center and in the guide, we have coconut shell carbon. Most of the time, those filters are used for very fine contaminants like VOCs. Larger pore sizes are applied for larger chains of molecules. Has anybody ever heard of a tannin? You guys ever heard of tannins? Do you drink wine? Anybody here drink red wine?